This is lesson 1.1, a review of properties of exponents. It is important that we review these properties because in Core 3 you will be learning about rational exponents and you'll be rewriting expressions involving radicals and rational exponents using these properties of exponents in the next couple of lessons. So let's get started. There are 5 key properties that we'll be going over: product of powers, power of a power, power of a product, negative exponent, and quotient of powers. For each of these, we'll go briefly over the rules, and then I'll give you an opportunity to practice each one. The first rule is product of powers. What the definition says is for any real number a and all positive integers m and n, if you take a to the m power and a to the n power, that equals a to the m plus n power. Essentially, if you multiply two expressions together with the same base, all you have to do is add the exponents together and keep the base the same. So here's an example using 3. 3 to the third times 3 to the fourth is saying that you have 3 threes times 4 threes for a total of 7 threes. 3 to the 3 plus 4 gives you 3 to the 7. Here's another example using a variable n. If you have n to the second power and n to the fourth power, what you have then are 6 n's. N to the 2 plus 4 power gives you 6 n's. All right, now it's your turn. So go ahead and pause the tape and try some of these on your own, and then when you come back, I will show you the answers and you can see how well you did. Okay. So hopefully you have all your answers. So let's go over the first one. This is just like that last example. We have n to the fifth times n to the third. So we keep the same base and we add the exponents. 5 plus 3 is 8. So therefore we have n to the 8th power. Now this one is a little bit trickier. What power is k to? Well, if you don't see a power, it's understood that it's to the first power. So what you have is k to the fourth times k to the first power. If you add those together, you get k to the fifth power. Okay. In this third problem, these parentheses still represent multiplication. It's just another way to show it. So you have y to the 8th times y to the 4th. Again, if you keep the same base, we still have y. And if you add 8 plus 4, you should get 12. This last problem is a little bit different. Now, if you remember, you have to have the same base. Well, 2 and 4 are not the same base. However, they are both constants that you know how to multiply together. So you take the 2 and the 4 separate from the a, and you just multiply 2 times 4, and you would get 8. Then you address your variables. So now you have the same base. You have a to the third power. You have a to the second power. If you keep your base, you still have an a. 3 plus 2 gives you 5. All right, let's move on to the next example. Okay, so the next property is the power of a power property. And what this definition says is that for any real number a and all positive integers m and n, if you have a to the m raised to the nth power, then you would take a raised to the m times m. So when a power is raised to another power, you multiply the exponents together and keep the base the same. Here's a couple of examples. In this first example, you have 2 to the third power, a little bit squished in there, and all that is raised to the second power. So essentially, you have one base of 2, and you are raising 2 to the third power to the second power. You just multiply, and you get 2 to the sixth power. Here's an example using a variable m. You have m to the fourth power raised to the third power. One base m, but now you would multiply the 4 and the 3 together to get m to the 12th. All right, let's try some examples. So try these on your own, pause the tape, come back, and we will compare answers. Okay, so let's see how you did. So here we have s to the second power, all that raised to the fifth power. So according to our rule, we would multiply our exponents together. So we have 2 raised to the 5th power, which means we then have 5 times 2, which is 10. The second example, we have a base of 10 raised to the 3rd power, all that raised to the 2nd power. Multiply that together. 3 times 2 is 6. Okay, now in this example, it's almost like we have 2 different problems. We have p to the 4th raised to the 3rd power and q to the 5th raised to the 3rd power, so we would take those separately. So let's handle the p first. We have a base of p to the 4th raised to the 3rd power, so that becomes p to the 12th, times q to the 5th raised to the 3rd power. Multiply those, and we get 15. Now notice these are different bases, so we're done. We can't combine p and q because they are not the same base. All right, let's move on to the third property. 3 out of 5. This is the power of a product. The definition says for any real number a and b and any positive integer m, if you take a times b and you raise all that to the m power, what you're saying is that you're actually raising a to the m power as well as b to the m power. Notice the parentheses. This power then is applied to everything in the parentheses. So in our first example, we have xy to the 3rd power. You would then take x to the 3rd power and y to the 3rd power. It does the same thing if you have a constant. So in the second example, we have a 3a to the 2nd power. So we have to raise the 3 to the 2nd power, just like we did with the x in the previous example. And we have to raise the a to the 2nd power. So what we have is 9, because what you have are 2 of these. So 3 squared is 9, or 3 times 3 is 9. And then a to the 2nd power is just a to the 2nd power, or another way of looking at it is a times a to the 2nd power. Okay, now let's try some examples. So again, once again, pause the video, try these on your own, come back, and we'll see if you have the same answers as I do. All right, so welcome back. Let's look at this first example. So in this example, what we have is ab to the 4th power. And so let's see what's going on here. So what we have then is a to the 4th power, and we have b then to the 4th power. Okay, remember that everything in the parentheses is raised to that power. In the second example, same thing. We have 4a to the 2nd power, so everything is raised to the 4th power, which means that we take 4 to the 2nd power and we take a to the 2nd power. We can further simplify that because you know what 4 squared is, and that would be 16. And then we can just rewrite times a to the 2nd power. Okay, in our final, well, not our final, in our third example, we have 2 variables. So remember that each of these is going to be raised to the 4th power. So m to the 3rd is going to be raised to the 4th power, and n to the 2nd is raised to the 4th power. So when we do that, remember that we multiply power to a power. So 3 times 4 is 12, and n starts off as n squared to the 4th power. So we multiply the 2 and the 4, and we get 8. Okay, now our final example. Again, we take everything to the 3rd power, so we have to take the 3 to the 3rd power, and we take x to the 3rd to the 3rd power. That becomes x to the 9th. Let's simplify this. 3 to the 3rd power is then 27, and we can then multiply that by x to the 9th. And we're finished. All right, let's move on to our last rule, and that is second to last rule. This is rule number 4, negative exponent. The definition says for any number a where a does not equal 0, and notice why we said that. A is in the denominator, and we cannot have division by 0. So for any number a where a does not equal 0 and any positive integer n, if you have a to the negative n, what that's saying is take the reciprocal of a. So really what this is this is a over 1. Take the reciprocal, and then we can say it's to the positive n power. We can do that for any variable raised to a exponent. We can take the reciprocal, but then we have to take the opposite sign of the exponent. So here's some examples. X to the negative 6 then is 1 over x to the 6. We took the reciprocal and we took the opposite sign of 6. In this other example, 5 is not being raised to a negative power. 5 is being raised to the 1 power, so we leave it where it is on top. But m is being raised to the negative 4 power, so we would move m to the bottom, take the reciprocal of m over 1, and we would change the sign. All right, let's give it a try on our own. So pause the tape, try these, and we will compare answers. Okay, on this first one, in order to make the exponent positive, you have to take the reciprocal of y, which is 1 over y, and then it can become y to the 12th. Take the opposite sign. The second example, 4 is being raised to the first power, so we can leave it on top. However, m is being raised to the negative 7, so we would prefer to move that down in order to make the 7 turn positive. The n is raised to the positive 3, we can leave that on top. In the bottom example, if we do exactly what we did in the top example, we take the reciprocal of 1 over s, which is then just s over 1, or s, take the opposite sign of negative 4 since we did that, and now it's positive. That's s to the 4th. In the bottom example, we have 2 to the first, n to the first, but then we have m to the negative 8. So let's take the reciprocal of 1 over m to the negative 8 and make it m over 1 to the positive 8. All right, final property, dividing exponents with the same base. This is very similar to the last property. So what that is saying on this one is that for any real number a, where once again a does not equal 0 because a is in the denominator, and all positive integers m and n, if you have a to the m over a to the n, you can just take the reciprocal of one of your variables. So in this case, we took the reciprocal of a to the n, brought it to the top, but then we have to take the opposite sign. So we have to turn it into negative n. These are the same bases, so we can combine them. Here's an example of x to the 5th over x to the 3rd. If we move the x up, we take the reciprocal, then we get x to the 5 minus 3, which is the same as x squared. So let's try a couple on our own. Pause the tape, try these, and then come back and we'll compare answers. Okay, on this first one, these are the same base. So what I'm going to do is I'm going to move a to the 7th up. So I have a to the 11th minus 7, which is the same as a to the 4th. Okay. In the second example, I'll do the same thing. I will move m up because this is m to the 1, and I want to subtract it from the m to the 4. So what I end up with is m to the 4 minus 1, which is just m to the 3rd. This bottom example looks complicated, but if you take each variable separately, it's really not that complicated. It's actually quite simple. So in this case, I'll make my dividing line, and I'll start with my x's. This is x to the 3rd over x to the 1st. I'm dividing those, which means I'm going to take the bottom one, take the reciprocal and move it up. So I will get x to the 3 minus 1, which is 2. And then same thing with the y's. I'm going to move the y squared to the top. So I will get y to the 6 minus 2, which is 4. And there ends up being nothing on the bottom. In my final example, once again, I'll draw a division line. Now on this one, the 5 is on the bottom. So I think what I want to do is move p to the 3rd to the bottom and subtract and get p squared. I'll move q to the 7th up. 8 minus 7 is 1. And that's it for your lesson on properties of exponents. Review this as much as you need.